So this is the document that I need you to start working down on your system. So determine the fit of the motor to the mechanics. Okay. With each of these, you're going to have to sit there and say, what does that mean? Well, does the motor fit? In this case, it's a NEMA 23 motor. It has a shaft length. It has a shaft diameter. It has a bolt pattern. The key for us in this is actually in any motor, go back to the camera for a minute. The key is this thing right here, this pilot diameter. There's a little block or little round part of every motor that sticks out a little bit. And the purpose of that thing called a pilot diameter that sticks out is so that when you attach it to mechanics, you don't end up centering the motor on the bolt pattern. You center it on, here, let me use a little bit bigger motor so you can see it. So you don't ever want to center the shaft of the motor on the mechanics using the bolts. Let me get it up there. Right? Because bolts have play, and then you're going to get it up there, and you're going to move around, click, 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 click. It's going to have a fair amount of play in just the bolts, and you can't have that. It's got to be, you've got to somehow figure out how to align shafts down to thousandths of inches. And the way you do that is you use this diameter here that is concentric with the center of the shaft. So almost all mechanics are going to have some little place where this pilot diameter almost snaps into. And that way that ensures that the shafts are as aligned as you can get them within the manufacturing tolerances. So you're making sure that the two shafts don't bang into each other. You're looking for the relative sizes, but your main thing is hole pattern, and this pilot diameter is really important to get in the picture. And if you design your own mechanics and use a motor, you need to use this. This is your alignment tool. Okay. So number 2, hook up end of travel limit switches to your controller. Well, there's a whole operation right there, right? That's a wiring diagram, and where's the switch, where's the load, how much current flow, there's all that kind of stuff to hook up a sensor. Is it NPN or PNP? You're gonna have to do some wiring there. Number 3, test the limit switch operation by manually moving the mechanics. So this is where you're going to need to backdrive. You're going to need to start testing to see, first of all, you got to get the limit switches working electrically in the controller and make sure the controller recognizes them. And then you need to start making sure that it recognizes it. But then the next thing you got to do is make sure that you do something with them. So number 4, verify the motion system is stable and controllable. That's what I mean by getting 2 motors turning with your controller on. It's just one line on the list, but it's actually going to be, you're going to be doing a fair amount of programming right there just to get it so the motors are spinning with motion profiles and defined distances. Sounds easy just to say it. Number 4, verify that it works. Yeah, okay. Now we're getting into all the limit switch setup stuff. Test the limit switch direction by running the motor. There's a whole bunch of things that if you're turning the motor clockwise, or positive, or whichever way you decided to call it, the motor shaft's going to spin one way or the other, depending on how you have it wired. And it's kind of not important which way, but you've got to look at it and say, oh, the motor shaft is going this way. When I point it, make it go clockwise. And that makes the stage go that way. And so it's going towards that limit switch. And so generally, limit switch operation is directional, meaning when the motor is going one direction, it's only looking for the limit switch that would be at the end of that travel in that direction. And the reason for that is so that if you hit a limit switch, you can actually command motion to come back off of it. If you just have one limit switch that does both ends and you hit it, what are you going to do? You got to go out there and manually move it. And if it's a lead screw, you can't even manually move it. So you generally need some way to hit a limit switch. This whole operation is very directional. So there's a bunch of stuff to get the direction right. Then number 7. Number 7 is kind of a tricky one. Calculate the inward placement of the limit switches based on maximum velocity. This is kinematic equations. You have a velocity of your motor, you have a deceleration rate that you think you can do based on the torque of your motor, and you have to come up with the distance that you can stop. So you're solving for x, the distance. And once you have that distance that you can stop, then you actually have to put the limit switch far enough into the travel so that when it sees it, it has room before it crashes into the end. So there's most of your sensors are in some place right now, but it doesn't mean that it's in the right place. So every time you go through an axis of motion, you always have to think about how far inward do you place those limit switches, and it's based on what you think is going to be the worst case of velocity, torque, deceleration, that set of kinematic variables. So you got to do a little bit of work there. I think you can do that by getting your physics book out and kind of going, okay, drawing some triangles and deceleration rates and solving for distance. Okay. Once you have that, then there's some other things, and learn how to actually stop motion. I don't want you to be stopping motion by running to a keyboard and trying to type stop, S-T-O-P. It's too late. You need to have something that, oh my gosh, generally the thing that I gave you for your e-stop, I gave each of you a power strip. And the power strip has a red button on it. And so now if you haven't been using that, it's time to start using your power strip and make sure that your power supply is powered off of that so that you can reach over real quick and hit the red button on your power strip, and that's your e-stop. That's your big red button, okay? Move mechanics, finally number 12. Hook up the mechanics, tighten the specs. Number 12 is when you first need your coupler.